Okay, hi. Today we are going to discuss about your assignment, the part 2 on setting an experiment to verify usefulness of variance. So we want to measure how useful, whether variance could be used to measure contrast of an image. So how we do that basically is we need to prepare sample images. So we have a low contrast and a high contrast image. And then from there, we measure the variance, and then we make sure that we want to check whether the variance of low contrast is consistently lower than high contrast. So you can actually download the images from Google. So you can go to Google, and then you can type, let's say, natural photos, and then you can go to images. So it will shows you all the photos of natural photos. In fact, any photos will do, and then you can right click and save image one after another. Okay, so to save your time, I actually have done that for you. I have collected 30 images and have zipped them and put it into your additional notes under variance test images.zip. So you can download that and unzip. So then, so you observe all the images here, not mostly, actually all of them has good contrast. So what we can do is to create the low contrast image, we can actually try to lower the contrast manually using IM-adjust. So that's why if you look at the assignment here, so you can actually manually lower the contrast of image using IM-adjust in MATLAB. Okay, so once we have low contrast and high contrast samples, then we can start to compute the variance using MATLAB. And of course, there are things that we need to do. Before that, we have to, because all images are actually color image, but when we measure contrast, we only want to measure the contrast of the brightness, not the color. So we need to do conversion from RGB to gray before we could actually measure the variance. And then once we have measured all the variance, then we can use t-test in Microsoft Excel to check for us whether they are significantly different from each other. All right. So you need to find out what is all these t-tests and what is the output of t-test, and then how you can make conclusion from the results of t-test. All right. So the objective is actually to make sure that this variance is useful in measuring contrast. So how do we design? Very simple. We have to verify that across our visual. That is, we make sure that we have the high contrast and low contrast image, which we already examined using our eye. So we downloaded the sample image, which all of them good contrast. If we use our eye to check, it's all good contrast. And then we try to use IM-adjust to manually lower the contrast of each of the image, so that we can create samples of the low contrast image. And then after that, we will try to measure the variance. And then the variances, we will do tests and make sure that they are significantly different from each other. Okay, so you can Google t-test. So basically, t-test will give you results of the probability, whether the two groups of samples, they are significantly different. Okay, okay. Now, of course, you can do that manually. Okay, for each of the image, you try to, do IM-adjust, and then you try to convert to gray, and then you extract the variance. But you need to repeat that 30 times. So that is a lot of manual work. And usually when we do experiment, we will have more than 30 actually. So it's not always feasible for us to do that manually one after another. So today I'll show you how we can create a script so that we can automate the process. So let's save this as lab assignment 2B. Okay, save. So today I'm going to show you how you can make use of dir. This is the function that we're going to use. Okay, you can actually check the selection, chart the help. So it actually helps you to list all the content of the directory, including subdirectory, including files. So with this, then we have the information of all the files and also subdirectory, and then from there we can get the file name for each of the image file, and then we can read them and use for loop to repeat the process. All right. So I'm going to start with, as usual, we're going to do a clear all. Okay, and so that we clear our workspace. Okay, next we are going to list all files and directory. Okay, so our list. So the output is actually an array of structure. So we have to put in the where we keep all the files. So this is our image directory. Okay, so before that, we have to define where our image directory. So you can actually get it from here. Okay, the directory where you keep all the image files. Right. Okay, so now we are ready to test it out. So let's run. Okay, so now you can see in the file list, if you double click this, so it's actually an array of structure. So this structure for each of these actually is the information about either a file. So in this case, you can refer to this field called name. So this is the name of either the files or sub folder. So we also have two folders here. So you also have one which is important, which you use later, is the indication whether it's a directory. So that will help us to filter out the directory and we'll focus only on the files. And if you notice that I purposely download all JPEG file. Yeah. Okay. So next. So then we are ready to actually use a for loop to go to all the files, one until. So let's say we don't know total files. So now how do we know the total files? Actually, not only files, but also include subaccess. So total files, actually, you use this number of element in this file list. So if you look at this image, this file list, actually there are 32 array of 32. There are 32 elements. So 30 are the image files and 2 are the subfolders. Okay, so you can check here. So we have 32. 30 of them actually are JPEG images file, and the other 2 is actually the subfolders. Okay, and then we need to make sure that because there are 2 of them which are not files, so we got to make use of this. Okay, for each to check whether they are directory. So we will only perform operation on those which are not directory. So I will put some command here. So loop to read each files. So if so we will only perform our operation like read the image and so on. And what else? Convert to RGB to gray, and to compute to lower the contrast. Also to compute variance. So all this will be done here only if it is file. So it's very simple. File list dot is directory. So we will not do this if it is not directory. So meaning we will only do it if it's not directory. So this is the not operator. Okay, so don't forget the array index. So we use our counter I in the for loop. Okay, so only if it is not directory, only we will read the image. So we will read image. So our img is imread. So we need to construct the file name, which includes the directory as well, image directory, and then follow with the file name. All this dot, press tab, so this thing is going to come up. So these are all the fields in this structure. So the name, and don't forget. Okay, so I put a slash here so that I can easily join this with the name later on. All right. And then of course we need to verify whether it works. So we need to do im show img. Okay. And then maybe we can put in a title. I mean, that is just for verification purposes, the file name. Okay. So then maybe we can pause it for 1 second so that we have enough time to view each image. All right. Okay, so let's try to run and see whether we can use the loop to display the image. Something wrong here. So let's see what the title. Oh, okay. Undefined function. So must be some. When you see this undefined thingy, okay, function variable usually means some typo error. So line number 11 here. So title. Right, let's run again. So then you should be able to view the image. So this is the image. So the title is actually the file name together with the path. Okay, so if you think it's working fine, then you to stop this loop, you can just press Control C. Okay, Control C. So it will break. Okay, so can temporarily comment this. So we don't need this at the moment. This is basically for verification. So next we can do convert to gray. RGB to press tab gray. Yeah, I am. So again, we can make use of this code here to check. Okay, so here we can use a subplot so that we can show two images together, the original gray and also the original and also the one after converted to gray. So subplot 1 row 2 column. Number 1, im show img, and then the title is original image. Okay, copy and paste. Great. All right. So I think we should use pause as well so that we could view. Again, run. So as you can see, when you develop code, it's always important for you to do verification by visualizing your results or to check variable. But in this case, we want to visualize the results depending on the operations that you want to check. Okay, so if you think it's correct, then we can Control C. Need to control more than one times if it doesn't stop. So next, we are going to lower the contrast. Okay, so I'll put it here. So I am to gray poor contrast. Yes. Okay, so in order to learn how to use this function, I'm adjust to reduce because usually previously we use it to increase contrast, but how do we use? So then you can use the online documentation help. Okay, so this is the syntax that we use. So you can define the range of input and output. So to lower down the contrast, so we use full range for input, and then we reduce the range. So the full range is low is 0, high is 1. And then when we want to reduce, so we reduce the range. So the low may be something higher than 0, and this one something lower than 1. So, okay, so we are going to put the input is IMG gray, input, output range. So input range, full range from 0 to 1, output range, of course, smaller range. So we use 0.3 to 0.7. So you can see that now we have reduced the range, so the contrast should be less. So now to display the ink, so we can actually IMG show, if you want to show all gray, this one show gray poor. This is gray and this is after become poor contrast. Okay, or maybe this one we put the good contrast. And as usual, we run so that we can check whether we have really, okay, so good contrast, poor contrast. So this is how we verify, make sure that we get what we want. All right, so once you're happy with this, then again, you can stop by Control C. Okay, next we need to compute the variance. So so to compute the variance, of course, you can always check Google, what is the variance in MATLAB. Okay, so we use this var, var var. All right, so so we have to, let's say this is the variance, which variance we call it. So put it J, we have two variants. One is the variance of image gray. Okay, another one is the variance of image gray poor, the one with poor contrast. So first column, good contrast, second column, poor contrast. And our J is the index. Why we don't use I? Because the I is actually including the non-file, the directory. So we have the J start with 1. And every time when we find it is a file, we'll do this, and then we will increase the counter J plus 1. All right. So all this now become contemporary commenting. We don't use it now. Okay, so we are ready to run. Okay, so if you look at this line 65, sorry, this is the variance. So they need some, the argument must be single or double. So this one was unsigned integer 8 bits, so we need to convert it to either single double. So I need to convert to double. So you see when you do developing codes, okay, it's important for you to check. It tends to encounter such a syntax error telling you that, you know, your data type or you have which one appears to change. So consider pre-allocating for speed purposes. Okay, so let's allocate it. So pre-allocate before we use here. So image variance. So pre-allocate zeros. So we want it to be 30, because we have 30 images. So 30, and then 2 columns. All right. So we pre-allocate, then the error will disappear. So now let's run. Okay. So you can see that the convenience of using loop. So if you do it manually, it may take like 1 hour. But if you do it using code like this, okay, this is especially true when you have not just 30, like if you have 3,000, then it's basically not practical to do with manual. So now we check our image variance. So this is the image variance that you have. Okay, so you will copy and paste them, Control C, and you can open up Excel. Okay, actually I have created that Excel, so I'll open that to save time. So you can paste them, okay. So once you paste them in, then this is what you get. These are the values, okay. So the first one is good, second one poor. Okay, maybe I just do it again. Okay, here and here, paste. So you will have this. All right. So this is good. This is poor. Okay. So next things you want to do the t-test. Let's explain in your assignment. So you look at the assignment t-test function. So what is a t-test function? T-test function is Okay, so now we are ready to do the t-test. So how to calculate the t-test? Well, t-test. So first array, and then comma, second array, okay, follow. And this one, because all positive values, so one tail distribution. And then whether it is paired or, so in this case we use paired because we are comparing the good and poor, because both are same image but different contrast, so it's by paired. Okay, so you get this in scientific format. So this is actually 2.6 multiplied 10 to the power negative 13. If you don't really understand, you can put it in number. And then because this is so small, negative 13, so change it to number, and then you have increased the decimal points. So you can see this is actually a very small number. Now, what is this number? So as I said before, the output of t-test is actually probability. Okay, so what is the probability? The probability that there is no difference between good and poor contrast. Remember, this is actually comparing the two columns, okay, by pair. So to check whether they have consistently a difference, a positive difference or negative difference. So in this case, if you check, it is consistently we have a positive difference. You calculate the difference between good and poor, you can see the difference is always positive. All right, so meaning actually there is a consistent difference or significant difference. So, and if you check with the probability is very low that there is no difference, meaning that there is difference. Okay, it's unlikely there is no difference. Okay, so how do we usually interpret this? Is we try to check with some threshold. Our threshold is actually 0.05, and this is obviously much smaller than 0.05. So meaning it's very unlikely no difference. Or in other words, there is difference. And this is consistent to what we see here. The difference is always positive. Now I show you another example where we have a non-consistent difference. Sometimes it's good contrast, sometimes it's higher, sometimes it's lower. So with this kind of inconsistent result, if you do the testing, you will get a very high probability that there is no difference, 0.37. So if this is the case, then you can't say that there is difference. So now in the experiment, we shows that, okay, the good contrast consistently higher than the poor contrast. And we do t-test and we find that, chances of no difference is low. So since chances no difference is low, so then what can we say about it? So we can say that there is significant difference between the variance of good contrast and poor contrast. Or in other words, we can use variance to measure the contrast, because the good contrast tend to have high variance and then poor contrast has low variance. So in other words, that variance is useful in measuring contrast. Okay, so this is typical steps that we do in experiments to verify whether a features could be used to differentiate, features. So when there's consistently differences in the samples, when there's significant different samples, then the features is good. Otherwise, then it is not. So coming back to this, so you can see what is the objective. So the objective here is actually to verify whether variance could be used to measure contrast. So how do we design? So what we do is we make sure we design the experiment to make sure that the variance of high contrast and low contrast is different. Okay, so how do we do that? So we try to download sample images, and then because all sample images has good contrast, so we do use IMadjust to lower down the contrast so that we have samples of low contrast and high contrast, and then we measure the variance, and then we use t-test to check whether each pair of good and poor contrast, whether their variance is different. So, and we use the t-test output is actually the probability. Okay, so if the probability is lower than threshold 0.05, meaning that the two called the two samples of poor and high contrast, low contrast, and high contrast image, their variance, there is difference. So and that has been shown here. Okay, so basically that is what assignment 2A is all about. All right, thank you.